do you want to do some demos? I'll let you take it away.
So why don't we do LandingLens first,
Mhm.
and then I'll kind of reset, and then we'll do agentic document extraction.
Okay.
So demo on LandingLens. So LandingLens makes computer vision super easy. You can start for free by clicking this button, and that'll take you into an interface kind of like this, but yours will initially be empty. This one is my demo interface. So we do offer quite a lot of different project types, and you get a sense for just the type of project problems that you can solve with this solution. But let's get into just exactly how it's used. So I had prepared this bird nest example using just 50 images. So this is drone photography. It's a visual inspection case for infrastructure, right? So when you're flying around, right, you want to detect these birds' nest. You could also detect like broken insulators. You could detect other things in the same images. But for this use case, we're just detecting these birds' nests. So first step is acquiring the images. Then you're just going to drag and drop the images. I did that in advance.
Okay.
And we've got 50 total images, of which 46 of them are labeled and 4 are not. So
Mm.
we can very quickly filter on the ones that are still needing labels. And here you're going to draw bounding boxes around the nests that you see. So this is an example of a task that doesn't really require any subject matter expertise. Um, and if you were classifying something like, semiconductor defects, which we had talked about before, you would need an actual expert to classify those.
But this is the labeling process for these images that you would call this labeling. You're basically outlining the nests.
Yeah, the 4 that I just did is
Yep.
labeling them.
Okay.
Yep. Yeah. So now I have all 50 labeled.
Okay.
And then for training, you can just hit the blue train button, or you can go into custom training. So if you're familiar with machine learning, here you're going to set your train and dev splits. So, 80/20 would be a common split.
Mhm.
Here you're going to select your training epochs, your model architecture, and then your augmentations. And I'll show you some of the augmentations just because these save people just a ton of time. So typically to make your model more robust in production, you would add some variation to your images. So here we're in like random brightness, right? And so
Mm.
what I'm doing is just kind of previewing this effect on the images. But if I apply some amount of random brightness to my training data, then it should perform better in dark conditions and overexposed conditions. So we offer quite a few different augmentations, and this is just a huge time saver because otherwise you would have to do this outside of the platform.
How do you know how to do this? Experience?
Yeah, yeah. I mean, like brightness makes sense for anything that's outdoor.
Yeah.
Horizontal flip makes sense for most things in the real world, right? Like an automobile or a truck can appear both ways, but you wouldn't
Right.
want to vertical flip an automobile.
Yeah.
Yeah. But with these drone photos, you could actually very legitimately vertical flip them, right? Because they can be flying at different angles. You could be taking a picture upward at the infrastructure or downward, and you would still want it to be able to detect. So here we've got some vertical flips.
Okay.
Yeah.
This is
Um,
cool. Okay.
yeah, and then yeah, feel free to ask me questions. I'm just going to hit the train button that spins up a GPU in our cloud.
What was the number on the train button?
It's the number of credits that that training run is going to cost you.
Okay.
So you reload your account with credits,
Yeah.
and the more images and the more pixels in your images, the more credits each training
Oh,
run will
okay.
take.
So it is
Yeah.
based on like kind of the type of images or the
Yeah.
content of the images. Okay.
So like these images are really quite large. These are like 8,000 by 5,000 pixels.
Oh, yeah.
You may not have noticed in the settings that they were actually downscaled quite a lot. So if I had chosen to use all the pixels, it would have cost more credits. So typically you want to find the balance between like, do I really need to use all the pixels? Like your model is going to be bigger, it's going to run slower because you're considering all the pixels in the
Mhm.
image.
Is this something you work with companies on, like kind of estimated cost and things like that when they're talking to you about the problem and you learn about all the images they have, the amount of data? Do you work with them on the cost? Like, can you estimate the cost for a given project or workflow?
It's actually really the credit part is really pretty negligible compared to the use cases that I'm solving in the enterprise segment.
Oh yeah, right.
Um,
Okay.
yeah, so one training run, I mean, like I think it was like 150 credits. I mean, that's like a dollar or something
Oh,
like
okay.
that. So yeah. Um, so, for certain individuals, you may actually, care about $1 versus $3, but for
Right.
most of the corporate users, like
Right.
they're not picking up the tab, and so they just hit the train button.
Yeah. Okay.
Uh, Yeah, so what we're seeing here is the different training epochs. So this is training a deep learning model. These are all based on convolutional neural networks. There's a lot of great courses about kind of like the fundamental math behind those. But this basically like obfuscates all of that. Like you don't need to learn the math of convolutional neural networks. You can just wait until this is finished and then look at the accuracy.
This is a single training run.
Yes.
Okay. Can you explain that? I think I know what's happening here, but can you explain that loss chart?
Yeah, so on the loss chart, lower is better. It represents the residual error in your dev set. So we're trying to fit the weights and biases in the neural network to the training data and then evaluate it on the dev data. And there's about, I think, 29 million parameters to be adjusting. So each time, like it's adjusting those parameters, it's
Wow.
checking the remaining error.
I see. So
Yeah,
you
and
want to get this as close to zero as possible, but it probably won't get to zero, right?
correct. Yeah. So on an easy problem, sometimes it will get all the way to zero.
Hmm.
So for example, well, let's just take a look at a finished version of this bird's nest. So this was done with more images. There's
Hmm.
391 here. Um, and we kind of keep track of your different experiments. So like as you do more, they get added to this table. This one was created quite some time ago. So like our loss chart after, an hour is pretty close to zero.
Hmm.
And on the performance report, you can see that there's actually no mistakes made on the training data.
Right.
And then in the dev data, there is one error.
Okay.
So this is actually a really, really excellent model. So here's like the 80 that it's getting correct, right? And it's
Hmm.
going to show you side by side the ground truth, which is how the human labeled it, and then the prediction from the model. So in this case, a human labeled 3 nests here, and we're
Hmm.
finding 3 nests, and you also see the confidence score for each one. So this is a good example of object detection where you can detect like multiple instances of the same object.
Yeah.
And then this model actually only made one error, and like this is actually a pretty difficult one to see. Like I can't actually see it at this
Okay.
resolution.
So
So
if you really wanted to bring this to like error of zero, like you let's say you wanted to fix this,
mhm.
how would you do it? Like, how would you train it to be able to handle that specific scenario where the nest is small and hidden? Is there any way? Or is it not even worth it because it's only one example?
In this case, it's probably not worth it. But the two ways to improve the modeling is to try different architectures and to add more images.
Oh, okay.
Yeah.
Got it. And
So,
that's across the board. If you want your model to do better, less error, add more images or change the architecture, you said.
yeah, so things like the augmentations, right? Like you can try different
Oh,
augmentations. You can try a larger model or a smaller model, like in terms of the number of parameters. Bigger is not always better. Sometimes bigger models with more parameters will actually overfit your training data, and a smaller
Right.
model will do better. So those are some of the things that you can try. You can also adjust the training epochs.
What do you start with in terms of the architecture? Is there just a standard you start with and then you tweak it if you need to? I missed that part when you started
Yeah,
training.
yeah. So the choices in the drop-down list are based on the project type. So because this one is object detection,
Oh,
there are there's really these
I
three
see.
reference architectures. So in our documentation, there's actually a link through to the papers. So like you can learn about like what is rep points, right? And then this one's 20 million parameters and 37 million.
Oh, I see.
And they can learn about these reference architectures. So our the architectures are not directly what's in those open source papers, right? But we have pre-trained models based on those architectures as published from those papers.
Oh,
And so
okay.
we're reusing those names.
All right. Got it.
Yeah. Yeah. Do you want to see any of these other projects that look interesting?
Oh, so at the end of the training process,
Yeah.
what does it give you? It gives you a fully trained model. Like, what does that look like? There's an endpoint.
Yeah. So let's see. Where's my, so I use this one all the time because it's connected to a video camera feed on YouTube.
Yeah.
So this one has been deployed, and once you deploy it, you can interact with it in a couple of ways.
Oh, I see.
So, yeah, so it's going to give basically like all you have to do is insert your API key and
Mhm.
then use our Python library, and you can interact with this model.
Nice.
You can also download it and use it at the edge. And so this is actually one of the demonstrations that I have set up to cloud inference as well as edge inference. So you could imagine like if you were this like city in Michigan, right, and you have this traffic camera already installed, you can actually like run the model locally, like right next to the camera, so you don't have to send everything to the cloud. And that can be a lot more cost effective to just have your own infrastructure.
Oh, that's interesting.
Yeah.
So, what does that look like in practice, though? They run it locally, and then what? It's storing all this information about cars that are what going through red lights.
So this is where it gets into the framing of the business problem.
Oh, right. I just
Um,
assumed that was the problem.
Yeah, yeah. So this particular one, again, this is a demonstration system, but
Yeah.
the idea here was to count the moving vehicles that are going through this intersection. So like notice that these two cars are parked and they're
Uh,
not labeled. And
right.
then we also kind of like drew a visual boundary. So like we're not going to count anything past this intersection, kind of where my
Yeah.
mouse is going back and forth. So we're just counting this primary intersection. And from this kind of counting, you would be able to count like how many large commercial vehicles are passing through this intersection. And so this could be, like part of a traffic or congestion study of like how many of these like commercial vehicles are coming through like what looks like the main town thoroughfare. So that
Okay.
was at least the problem statement that I had devised, right? Here's also a pedestrian illegally crossing back there.
But like, if you're running this model locally, like you said, next to the camera, how do you retrieve the output, like the information that you're trying to capture from the images?
Yeah, so it's going to come back as a JSON response.
Oh,
And so, and let's see, what's the best way to,
I got it.
um,
Yeah.
yeah. So, um, where's the models? Uh, okay. So when you deploy the models, like we were looking at object detection for both the bird's nest and the vehicles. So you're
Hmm.
going to get back a JSON response, which will give you if an object was found and then like the
Oh,
boundary
I
box
see.
coordinates for where it was found.
Right.
So this is basically what you get back.
Hmm.
And so you're going to get a probability that something is of a particular class and then the coordinates. And then part of like designing their pipeline is often the like, okay, now what do you do with this JSON response?
Right.
Like you still have to like insert it into a Tableau dashboard or whatever else you're going to do with it. And especially with video, if you're doing like, 10 frames per second, suddenly you have like, a million JSON responses and you have to do something with that.
So in LandingLens, you demonstrated like basically feeding a lot of images. Can you feed video files and then label those, or no? It's only going to be images from video files.
We don't natively take in the video. You do
Okay.
have to convert it to images. Right? Like here would be another example that most people
Yeah.
can relate to, right? So this would allow somebody to do like an efficiency study to say like from the time that the aircraft arrives at the gate, how long does it take for the staircase to arrive? How long does it take for the baggage loader to arrive? Like,
Mm.
how long does it take to connect it to ground power? Like, so you do need individual frames. And in this case, it's an example where you can detect lots of different people. And in that kind of like efficiency
Mm.
study, you're not really interested in like, did I get all 27 people? You're more interested in like, did I get the arrival of the baggage loader?
Yeah. Right.
Yeah.
Oh, that's cool. Okay.
Yeah.
Great.
So yeah, so that's LandingLens. There's
Hmm.
more information about it here, and there is the ability to start with a free account. So
Okay.
it's great for students. I know some faculty members actually do use this free account like in part of their course. We have a huge number of semiconductor customers, like that's probably the largest segment.
Yeah.
And also providing like vision for robots. So,
Mm.
like we have a fairly large like public relationship with ABB Robotics. So if you
Yeah.
think about like industrial robots, they don't actually have any eyes to like see the task that they're doing. And so being able to partner with a robotics company, we can basically like give those robots eyes so that they can see what they're doing on the factory floor.
Oh, yeah. Right.
Yeah.
Great. You have time for ADE?
Yeah, let's do it. This is the main product page for agentic document extraction. And you can also try this for free. Click this white button. It'll give you a chance to create an account either in the US or the EU, and it'll give you some starter credits to play around with. So this right here is what we call the visual playground. And it's a place where you can just drag and drop a file to kind of see what this does. So one of the demos that I do pretty frequently deals with utility bills. And I realized I have to come out of full screen to be able to show that.
Mhm.
Um, so here's a couple utility bills. There's a couple that are photographs. There's a couple that are kind of like digital native PDFs. But this would be a great example of like lots of different gas and electric providers. All of these
Mhm.
look a little bit different, but they all have the same information on them.
Okay.
So for something like a field extraction use case, utility bills are often provided like as proof of address. Sometimes they're provided like as part of like applying for solar credits or things. So we've worked with quite a few customers where like they're taking in these utility bills and they need to extract standard information from them. It's also just an easy to understand example.
What is this doing now? Is it automatically detecting what salient information?
Yeah, so it's called agentic document extraction because there's actually a variety of agents that orchestrate the process, which is kind of just this spinning circle at the
Yeah.
moment. Um, so the
Okay.
spinning circle has detected first the layout of the document, the different chunk types, and then tried to interpret the meaning of each of those
Mm.
chunk types. So, like right now, we've got like a margin chunk
All
type,
right.
like a
Yeah.
table chunk type. This is a text type. And this is a particularly difficult document because it's a photograph and it's kind of rotated. But we're trying to pull out all of the detail from that document.
Hmm.
Yeah. So what you get back is a markdown response and then also a JSON representation of the entire document.
Hmm.
So then you can start to say, okay, well, like here was another one that I did in advance, right? This was one of the other ones we saw. Here was another utility bill we did in advance. So now from a customer's perspective, like they can save this markdown or save this JSON, and they basically like have a true representation of the original document.
Yeah.
Um, and then you can go on to start to extract fields from it.
Okay.
So this is the, visual playground. It allows you to just kind of build up a schema from scratch. So you might say, total amount due, and that would be a numeric, and you can run that schema. So this is now going to pull out that key value pair. So like I've given this variable name, it's going to find me the total amount due, and it's going to be a reusable schema that I could then apply to like all of my utility bills.
Utility bills in the same format.
No, quite
Okay.
specifically different formats, right? So like none of
Gotcha.
these
Yeah.
are actually the same. They're
Yeah.
from different power companies. They have different layouts. So the whole idea is to get rid of layout specific
Yeah.
training.
Mhm.
Um, that's kind of like the history of document extraction of like you can find a good like 1040 extractor, right? Because like the 1040 tax form like hasn't changed for a long
Yeah.
time, and like
Right.
people have actually trained a model for like finding every field. But if you just like drag and drop some random, I don't know,
Yeah.
handwritten birthday card, right? It's going to recognize that just as well.
Oh, so how does this do with written text? Really well?
Yeah, actually performs really well on written text. I don't. Let's just do another one. So can open another tab. I was actually talking to a German team yesterday, and I was like, "Hey, like I have something in German. Like let's just toss that in, right?" Um,
Yeah, I
so
was going to ask you about like multi-language support.
yeah. So no problems on the multi-language support. I'm going to drop in my absolute favorite example because it's just fun. So we spoke with one organization that was interested in extracting dietary claims from food packages. And
Oh,
so they wanted to extract things like, does it claim to be non-GMO? Does it claim to be like gluten-free? Does it claim
yeah.
to be keto friendly, right? And so they had all of these, tens of thousands of product packages. So as part of preparing a demonstration for them, I was like, okay, well, let me go grab some product packages. And I found this macaroni package that has probably like 5 or 6 different languages on it. We'll let it finish extracting.
Mm.
Um, so, um, but the health claims thing actually worked really, really well. So they defined a schema of a whole bunch of Booleans. So like claims to be grass-fed, true or false, claims to be keto friendly, true or false, claims to be like USDA certified, true or
Oh,
false.
okay.
And so then they could go through like their entire inventory of product photos. Um, and that particular group, they were interested in if you modify the packaging to like add a particular claim, does that change sales? Right. So, like, this was the group that was actually working with manufacturers on their product packaging,
Oh,
and they
wow.
were trying to translate the appearance of certain health claims into like sales of that product.
I like the recipe on here. It's jazzy macaroni and cheese.
Yeah. Yeah, so that part is in English, but you can see just kind of like the mixed
Yeah.
language throughout. So, um, yeah, and it's also a great way to say, like, you could train a model to understand 1040 forms, but you wouldn't be able to just drag and drop a picture like this and be able to
Yeah.
get all of the text extracted from it.
So the idea is you could then feed different images of different packaging and look for all that same information based, like the initial configuration that you mentioned, right? All those Booleans and identify across all those different packaging if those products mention those specific things.
Yeah. And I think it's actually one of our demo project. So we have this public repo called ADE helper scripts, and
Mhm.
this is where we publish a lot of our demonstrations. So yeah, this one, basic field extraction using product images. And let's see, do I have a picture of the product images in here? Yeah, so here were some of the example images, right, that have various health claims on them. And then in the final schema, where is,
So that
yeah,
first image you showed,
mhm,
what was the first one? It was
this yogurt
yogurt.
brand.
It says
Yeah,
100% grass fed.
yeah,
If you brought that in and you wanted to identify, is this made from grass fed? I guess you don't care about 100%. It just says grass fed. So it's a Boolean of true. Is that the idea?
yeah, that's
Okay.
a good idea.
Okay. And then organic might be another one, right? A2 over A2. We don't care what that is. We don't even know what that is, but it's organic.
Yeah.
Okay.
So you can define your own schema, right? So this is all
Schema, right.
completely within your control. So in
I
this
see. Okay.
particular one, right, like we're extracting things like the product name or like the flavor,
Mm-hmm.
right? And then down here you get into all of these claims. So like is
It's
grass
grass
fed,
fed.
is
I see.
pasture raised.
Okay.
So this is all completely within your control.
Mm-hmm.
And you can do this in the visual playground.
Mm,
And then these are all examples of like actually moving to doing it in code.
I see.
Yeah. Um,
Wow, that's cool.
yeah. So like I'll just flash up a couple other examples, right? So
Yeah.
with the utility bills, right, you can upload a more extensive schema, right? Extract all of this structured information. And then this is an example of like how you would want to insert that structured information ultimately into a table, right?
Mm.
So you may have like all of your starting bills, and now you have like all of your structured information extracted from all of your starting utility bills.
Oh, wow. Okay.
Um, and then we're dealing with a lot of handwritten medical forms. So, if anyone listening to this is struggling with checkboxes, like we've spent a lot of time optimizing this model for checkboxes.
Mm.
So, being able to understand responses like this, like which of the boxes are checked, or something like this on like a PT intake form, like what has been circled, or like down here, like which of the values have been circled.
Oh, wow. Okay.
So we're working with a lot of handwritten medical forms, right? Where like it's really important to get all of those details right. Um, and then I think we had talked a little bit about RAG. And for RAG, people are usually dealing with like more like scientific documents where understanding the text is usually not a problem, but being able to understand the figures, right? So like this will provide a really rich description of what is this figure or what is this line chart trying to show.
Is it interpreting the visual, like the non-text portions of that, though, or is it just the text that it's looking at?
It is interpreting the figure as its own chunk, right?
Okay.
So when you think about the agentic workflow, so first we're detecting that this is text and this is text, right? And then
Yeah.
this is block 34 and this is 35, right? Because it has detected that it's a two-column layout.
Mm-hmm.
And then this figure number 39 is sent independently to an agent that is optimized for interpreting these figures, right? So it's going to say this is a
Mm.
diagram illustrating the cuff reflex pathway.
So, in general, if your documents have images in them, this supports that.
Yes.
Okay.
So like anything dealing with like complex tables, like tables that don't have clear grid lines are often a really big problem. So like this looks like a simple table, but an OCR system actually has a lot of trouble with it because there are no grid lines
Yeah,
provided
right.
on like how the table is laid out. Um, like here would be another one with like doesn't have any clear grid lines.
Mm-hmm.
And then also like if you have any photographs embedded in, uh,
Yeah.
so like something like
So,
this.
what does it do with this? It's going to interpret this.
Yeah, so I was going to say, okay, so chunk number 62 is a figure and it's a coronal
Mm,
CT scan of the paranasal sinuses.
okay. Those are all separate blocks, right? Those are separate images, or is that one block?
So in this case, it has detected these three together and then these separate. And that's
Oh,
part
right.
of us still like trying to improve our model. Like you could argue, I would probably prefer all five of these to be separate chunks.
Oh, okay. I was imagining the opposite, like it would be one, so then it could like compare them, or is that not really what you're looking for? In other words, like to compare those images or find consistencies across them?
So typically for something like this, you'd be doing this process because you're trying to prepare these documents for RAG for some sort of like expert retrieval
Yeah, right.
system.
Okay.
Um, and so in that case, it might be like if a physician or a researcher is asking about, changes in the nasal cavity during like the common cold,
Yeah.
it would be able to retrieve these figures, not just retrieve the text chunks.
Right. You just want to know what's in the image, right? Descriptions of what's in the image. It's going to be interpreted later.
Yeah, this is really about preparing documents for
Yeah.
RAG. So like this particular one, so this is ultimately like what
Oh, I see.
happens with these documents.
Hmm.
So these are all of my sample documents dealing with the common cold, right?
Hmm.
So these are some of the ones we just looked at.
Yeah.
Right? And so you're going to be able to prepare this now for RAG to say, okay, like here's the actual chunk content.
Hmm.
You might like throw away some of the margin chunks and say, like, I don't need those. Um, you would know kind of where on the page it's located. And then here, like each chunk also has an ID. So if you wanted to like expand the context window around a particular chunk, like you have the
Hmm.
previous and the next chunk. So I would think of this as just more intelligent chunking
Yeah.
because like a lot of preparing documents for RAG would be just like every
Right.
200 characters or every 3 periods. But this is going to be a much more intelligent way to prepare the document for downstream RAG.
Got it. Yeah. So a big part of this is the chunking because especially when you're preparing it for RAG. That makes sense.
Yeah, so there's like the two main use cases again were like field extraction of like, somebody has provided this bank statement and we need to
Mhm.
extract like the final balance or
Mm.
like taking these more or like these kinds of handwritten documents has been a huge use case. And then like preparing scientific documents for RAG.
Yeah.
And in that case, like we're working with a lot of pharmaceutical companies where they have a lot of unpublished research, but they have scientists all over the world, and like most of the research is actually in a file drawer. It's not published.
Hmm.
And so for a pharma company to continue to benefit from like its collective experience and everything that's in the file drawer, they're actually like digitizing a lot of their unpublished research findings so that they
Mm.
can continue to comb through those.
Wow, this is cool.
Yeah.
How much of this changed? Like you said, this tool has been around, right? It's been around for a while. But like I imagine there was just a drastic change in the underlying technology like 2 years ago.
So this agentic document extraction, we launched this in March of 2025. This is less than a year old.
Oh, I thought there was another version of it though.
Oh, I guess I was referring to just kind of like traditional OCR, right?
Yeah.
Like there's a lot of different OCR tools,
Yeah.
but they will typically completely ignore all of the figures and they'll mess up the tables. And
Hmm.
even with something like the text, they'll basically like read straight across here. So it'll go from like
Oh.
viral infections are, and then it'll go to the host.
Oh, it's that
Um,
bad?
yeah, there's actually
Wow.
there's a really interesting research paper where somebody using OCR had like accidentally read across the columns in some scientific paper. And then that particular sentence, even though it was a nonsense sentence, got like republished in like 30 other papers.
Whoops.
So
Wow. Okay.
so
Wow.
lots
Cool.
of fun stories, but this has been super fun. The documentation is pretty robust. You create your own API key, and then there's a lot of information in the documentation about like how to get started with setting the API key and how to use it programmatically.
So if you're gonna integrate this extraction tool into some other product, you're just gonna use the API key and do it programmatically, right? This is what
Yep.
developers are doing. Yeah.
Yeah. So it's allowing like the use case owners and subject matter experts to do a lot of the testing on their own because there's no coding required here.
Mhm.
And then they can pass it off to the developer and say like, okay, here's like our final extraction schema, like
I
go ahead
see.
and run with it.
Oh, I see. Okay. All right. This was great.
Good. I'm glad you enjoyed it. There's a lot of cool technology here.
I appreciate you taking the time. Nice meeting you. Thanks again, and I'll be in touch within a couple days.
Okay.
All
Bye-bye.
right. Bye. Thanks for watching. If you like this, be sure to subscribe. More interviews and demos coming soon.